Hi guys, Yavuz here. Today I will not only talk about the champion generator I chose, but also about the generator cover, about how to convert it to natural gas and propane, how to connect it to your house, and how to monitor your energy using a home energy monitor. It will be a long video. I split it up into chapters. Feel free to watch whichever you like. And I also added the links to the parts I purchased into description of the video. Today I will not give you a comprehensive review of a generator, but instead I will explain how to connect and run the system to your house in case of emergency. So the generator here is a Champion 100 520. You can find a lot of detailed reviews on YouTube from other people. They are great. I don't want to go into details of the generator, but just to quickly explain, while you are choosing a generator for your house or home, you may want to prefer an inverter generator because of the circuits inside. They generate much cleaner energy compared to other bigger rated generators. So that's measured by THD, total harmonic distortion. So the acceptable is below 5%, and usually the bigger generators run up to 20-25%. This is below 3%. What that means is that the shape of the sinus wave for the power is almost perfect. That means your electronics will not behave strangely, will not react to the power, your UPS systems will not shut down, and you will not risk having a bad quality electric at your home. And the problem is when you go to inverter generators, your capacity gets limited. So this is one of the biggest ones, largest ones I could find, which is like 7,000 watts running power. And you can also get a Honda for triple price, but Champion is a very reliable brand. So again, just to quickly mention, there are 120 outlets on it, which is as usual like your regular outlets, but what we will use to connect to our home is this 240 outlet. So this is called 1430 outlet, and I also will show you my panel and the outlet I built, which will connect to this outlet here using this yellow cable. So let's talk about natural gas or propane conversion. The generator is now running on gasoline, but if there's an extended period of emergency for days, then most likely the gas stations will also run out of power and you cannot buy enough gas to run your generator continuously. The second problem is that the gasoline contains ethanol, which absorbs water from the air, and it gets bad in a very quick time, like 3 months. If you don't want that to happen, there are fuel stabilizers which you need to put into your fuel so that they can stand up to 1 year, but still that's a limited period of time. You need to drain or choke your carburetor by shutting the gasoline valve before you stop the generator, and you need to store it properly. Meanwhile, natural gas especially is a continuous source of energy, so it is always a good idea to run it on natural gas instead of gasoline. At least have natural gas as a backup option to connect for continuous operation. So for this purpose, apparently the generator comes gasoline only, so it's not a tri-fuel or dual fuel kit. So I bought this conversion kit from US Carburetors, which is called Motor Snorkel. It comes with a regulator in it. I put these nipples on to both sides, What regulator does is once something sucks air from here, it opens the gas supply and feeds the gas into the line. If generator stops running, then the regulator shuts off, so there's no leak of natural gas. You can also connect propane to this kit, provided that there's another regulator between the propane tank and this regulator. So this is an adjustment screw. I hope I will be adjusting only once for proper operation. This makes sure that there's enough gas going into the engine for running. So it comes with an innovative piece of this gasket. What you do is you put this between the carburetor and the air filter box. So this goes into the carburetor, and gasket replaces the original custom gasket on the generator. So the good thing about this kit is this has a flexible nozzle, so you can still operate your choke, hence run the generator with gasoline, because choke will just smash it this way, but once you open the choke, it will go back to its original position. So it feeds gas directly into your carburetor. So I will be installing this kit. It comes with bolts and other stuff. The thing is that I need to install a valve here to cut the gas off on this side as well, because if you decide to run the generator without gas, the engine would still suck air from here, and it would create a vacuum leak, which is not desirable. So I will put a shut-off valve here as well, and I'm planning to install it just right here to the frame by drilling the frame, and then the gas would go to the carburetor from this. So here's what I'm doing. I removed the gas tank. It has 4 screws, and just you need to unplug the carburetor, and of course you need to shut off the gasoline valve and drain the line by running the generator a few minutes, so that I can easily drill these 2 holes without damaging the gas tank. Secondly, the air filter has 3 nuts, 2 nuts and 1 bolt here. So I just opened it up a little bit. You need to take out this flange which came with the unit itself, and you need to put this kit in. So one thing you need to be mindful here is that the hose must pass the choke plate. So once you close the choke, so it will be just smashed as I explained. So once this is done, then I will close the filter back and install the regulator here. I have only one hand, so see you. So now everything is put back on. The hose coming from the kit was very short and it was bending, so I had another 3/8 hose I could use from my other projects, so I made a longer one. Cable ties came out of the kit. Still, I need to put a valve here, as I mentioned before. If you don't turn this hole, so to say, off while running on gasoline, it will create a vacuum leak. So if you decide not to run on gas, there should be a valve here so that you can just close this hole off for proper operation. Gas tank is put back on, and once the connections are done, we will give it a run and adjust. So now the connections are complete. I have a 1/2-inch hose, 10 feet. The suggested maximum distance if you are using 1/2-inch is 10 feet for this engine, which is 13 horsepower. If you have a bigger generator, more than 7,000 watts, and if you go a longer distance, you will need to upgrade to 3/4 of a hose. So my main gas line is coming 3/4, which is good, and it will go down to 1/2 inch using the quick connect. There's also a valve here to turn the gas on, and I mentioned before there's another one here, which is kind of confusing. You need to always look at the sign. So it's closed now. I will turn the gasoline off, which is off now, and first I will run the engine so it will get all the gasoline in the carburetor. Running with the gas now. The next thing I would like to show you is this Igan Generator cover, which I bought from Amazon. The idea is great because the other tents are too tall, and also I'm not sure if they can be used for storage, but this idea came great to me because you can both use it operationally and during storage. So it has a frame which you put together on. The thing is that this did not perfectly fit my generator because these two rods were horizontal instead of vertical, so I had to change these plastic holders from this side to that side and shorten the rods so that they need to cross with the frame of the generator. There are tie straps which you can tie. I think there are 10 of these, which are good quality, so to hold it in place. And then there's this skirt which goes all the way around, and all the sides you can fold them up and hang them up back to the cover. So during operation you need to raise the three sides of it except the control panel, and during storage you can all lower them down. And there's a big lid on it which is also connected with Velcro strips. One side can be easily opened for refueling the gasoline. The problem is I left my generator overnight last night, and puddles start forming on this top lid, and I think once the puddle forms it starts dripping from these, either from the fabric or from these stitch lines. The great idea, I don't want to return it, and I want to modify and use it because it looks cool. It's not tall, it doesn't look ugly, and it serves dual purposes. One idea I have in mind is I will use this Flex Seal liquid rubber to spray over the top of the lid, especially on the stitch marks. And if that doesn't work, I will get an acrylic cover, a clear acrylic cover from Homedepot, and I will put it as a cover on it while I'm storing the generator. So if it rains, it will just flow over the acrylic cover. Most probably I will hold it down with a kind of weight or something. Here is after the skirt is installed. You can see it's all Velcro all around. Everything is working using Velcros, and the lid is also supposed to stick on it. These are also Velcro straps so that you can tie this valve to the generator. One thing I need to mention, two sides are different. This side has 2 bars and this side has 1 bar. Apparently the reason is that you can use the handle while the cover is on, and also this side of the skirt has shorter stitches here so that it can just be folded up. So the idea is you just fold these up. There are hooks under these so that you can just hang them back up to the again the idea is great. This is the lid, so all four sides are covered and you can raise all four sides. They recommend that you should at least raise 3 sides during operation. The idea is great, design is great, the quality is bad. So you can supposedly fill the gas tank using this part, but as you can see, for that purpose there is no velcro here. Last night it was puddling right here, so this was full of water, and apparently from here the water goes inside and starts dripping, and that's a bit bad because my power panel is just at the front of the generator. It's not on the side, so once it drips, it starts dripping right on the electronics. That's why I'm planning to, let's see if it works. So I'm planning to use this flex seal to spray around the lid and see if it will hold tight. If not, again, I will get an acrylic cover from Homedepot and I will put it on this so that it doesn't puddle anymore. Another option could be just to put some spacers under this so that it doesn't stay low but it stays high, but I don't know how much. So I sprayed black flex seal on the stitches, around the stitches. I don't know whether it will work out or not, but what I did also is I bought an acrylic sheet from Homedepot and cut it to the size. I could have put a larger acrylic sheet, but then first of all, how will you hold it down? Secondly, it may look ugly. So what I'm planning to do is just put this under the velcro and cover the cover up, so hopefully if the lid leaks, then there will be still some hope that the water will not go in. So let's talk about how to connect a standby generator to your main panel safely, so that you can run some of your circuits, if not all, during an outage. So this is my main panel in my garage. Most of the houses, I think all, would have two 120 volts coming into their panels, and some circuits like ACs, oven, dryer, they operate at 240 volts. So they get that power by adding up two different phases of 120 volts, which equals to 240. So when you open up your panel, which we will do in a few minutes, you will see two different lines coming in. It's important to find out which circuit breakers are feeding which circuits, because when you run your generator, some of the loads will be extremely high for your generator and you need to keep them off. A few examples is your electric oven, electric dryer, and then air conditioning units, the compressors, because these draw a lot of current during the initial startup, so generator cannot feed it unless you have them fit with hard start kits. The most important thing I want to show here is this utility kit. Again, you can find this in the description. I bought it from Amazon. It came with the template, so I could drill these holes to the panel. The purpose of this one is to prevent you flipping up the generator switch while the mains is on, because if you keep this on and then you run the generator and connect it to your panel, that means you will be backfeeding the grid with your power, which can create safety issues for the maintenance people working on the grid, or at least like your generator would not be enough to feed the whole neighborhood. So once you flip this switch off, then you can move this up and then only you can turn the generator power switch or circuit breaker on, which is feeding our panel in a reverse manner. Instead of power going from panel to the load, this time it will be coming from generator and will be feeding all this power. I put these red labels here so that once you want to start your generator, the procedure is that you flip off all these circuit breakers so there's no load at all. Then you flip off the main, you flip on your generator, you run your generator and plug it in. Then you start turning on the circuits one by one. And then these red stickers are for the circuits which would never be turned on while the generator is running. First of all, I don't think I would need a dryer in an emergency situation. AC is debatable. I mean, you can still live without it. But I mean, they are very high load, so you should always keep them off. If you load the generator, if you overload the generator, two things will happen. First of all, it will give an alarm and it will cut off the whole power. If not, then your voltage will drop, your frequency may change, and you can create damage on your electronics and other stuff. So it's very important to keep the power in control. That brings me to another topic. I want to monitor how much each generator 120 volt phase is powering my house. I want to know that so that I can balance the loads and I can turn the devices off if I'm exceeding or approaching the capacity of the generator. Some people I have seen on YouTube, they did basic displays, buying some displays measuring the current and the voltage and also the frequency from the line. They bought also project boxes, have them installed, and they powered it up, but it would cost you like $30, $40, $50. I found another solution for that. I need to open up my panel. Okay, so now the panel is open. If you don't know what you are doing, never open this panel, because whatever you do, there will be live terminals in this panel and you may get electrocuted. So as you can see, two main 120 volts are coming from the street grid, from the transformer on the street, and then they are feeding under these yellow caps whole bus bar, and the circuit breakers are connected to those. So this is our main switch panel. Even if you switch it off, there will be still power here, so it doesn't put you in a very safe situation. These are the ground bars, or neutral bars, so to call. In most houses, the neutral and ground comes together in the main panel and becomes one. So once you use the power, it's drained over these ground and neutral wires. So I showed you the Interlock Kit. That Interlock Kit must be compatible with your main panel. This is a square DQO panel, 200 amps, and your generator circuit breaker, if your main switch is up, then generator circuit breaker must be the right top circuit breaker. If your panel is upside down, then of course it will be the lower bottom one, left one. So the reason is that Interlock Kit is specially designed for this panel so that it can really control these switches. So this also comes from that kit, so it prevents people opening this panel during emergency operation or regular hours, and then there are warnings on it about the dangers. So once you may need to move some of your circuit breakers down so that you have two slots free here for generator. Again, one cable is coming from generator. The red one is 120 volts, and then there's the black one, which is another 120 volts, and it's feeding all this panel with 240 volts. Some circuits use 110, which is taken from here. If you don't have space in your panel, these double breakers are called tandem breakers. So you can just put two loads into one, and then you can create space using those tandem breakers. So as you can see, I just pulled a cable from here, this one, the thick one, which is a 10 gauge cable for 30 amps, and I just went through the brick veneer and also the drywall, and I will show you the outlet now. It comes out here. As you can see, this is a 30 amp 1430 outlet, so that you can connect your generator here. This one is a good one because it has also a light on it. Of course, this is not live because the generator switch is not on unless you turn off the main power. If you turn off the main power and flip the generator on, then again there will be no power here because there's nothing coming from the grid. So you just plug your generator here. So when we come back here, you will see those white cables and white sensors. What are they? Okay, so I told you that I want to monitor the power of the generator, how much power is coming on each line and what's the consumption, right? Then I found out this solution. Emporia Smart Power Manager is a small box which comes with either no connectors, no sensors, or 8 sensors or 16 sensors, or you can buy individual number of sensors. This unit connects to your Wi-Fi, and there's an app for it which you can monitor all your circuits separately. So it can tell you which circuit is consuming how much power energy in a certain second, in a minute, in an hour, in a day, or in a week, or in a month. So ideally it would also match your energy bill after 1 month of consumption. So this is really pretty easy to install. Again, you need to have someone who knows what he is doing. So you just connect all your sensors to this small box. You also power up the box, which measures the voltage as well and also powers it up. And there's also a small antenna here, Wi-Fi antenna, which needs to be outside of the panel. And then it comes by default with 2 main sensors which connects to your mains. So these are clip-on sensors. You don't need to remove any cables. You just clip them on to your lines. These 2 big guys are responsible to measure how much energy is your whole home consuming from the main loads, right? It doesn't show anything individually, but this is the total consumption. So there's a small arrow, KL, so the load must be always pointing to the load side. So the box in its simplest kit comes only with these 2, and then unless you buy a kit with 8 or 16 sensors, you can buy these individually. If you want to monitor just your generator, all you need is 2. So then you start connecting, clipping these cables. Of course, everything must be turned off. So you start connecting these clips, sensors, over your hotline in every circuit breaker you want to monitor. Again, it's important to know which circuit breaker is feeding which circuit, because mostly I'm not interested in 15 amp ones because usually those are lights, but I'm more interested in my oven, dryer, ACs, my EV charger, and then my pool equipment. So I just chose 16 of them which are important for me, and I connected each of these without losing track of which cable is going to the box. Here's the trick. So AC1, AC2, these are all 240 circuits. Same for oven and dryer. But these are balanced loads. That means if you have a current in one phase, and the current would be almost equal to the other phase. So you don't need to clamp two sensors, you just clamp one sensor, and in the app there is a multiplier, so you just multiply it by 2. So if one sensor consumes this much of power, that means your total power consumption is double that one. Okay, so this is how you connect. The sensor cables are pretty long, so that's what I didn't like about the sensor. You need to stuff it inside your panel, but other than that, I think it's a great kit, and you can get this for $150 including 16 sensors, which is really great. Okay, so again, for the EV charger and also some other equipment like pool, if they are all 240, that means you have balanced loads. But if you have something on your pool panel which is 110, that means it's either getting from here or here, then you may want to put 2 sensors. But in my case, I have the cleaner booster pump, I have the pump, I have the water heater, all of them are connected to 240, so it's a balanced load. I just need one sensor. Coming to the generator, now the story changes, because generator will never be balanced, because some loads in your house are 240 and some of them are 120. That means one phase will always draw more or less current than the other one. So you need to monitor both phases. That's why I put 2 clamps, one on red one on black one, and the app has a great feature that recognizes these sensors as a generator or solar power. Another thing to mention here is that this time your load is reversed, because load is not on your right anymore, it's left, because the power will come from the generator and feed this circuit. So the main panel is your load now. This is the way you can monitor. You can also set up notifications from the app. For example, if you say like you should not be exceeding 29 amps in a 7000 watt generator, my champion, in each line. So if it exceeds 29 amps, you should get an immediate notification and you need to switch some loads off. That's what I did. That's great. Either of the circuits should not be exceeding 29 amps in my case. So you can also find the link of this one in the descriptions.